Last year I took this picture from a helicopter over our monitoring site in Svalbard. It's a permafrost monitoring site. And generally the permafrost is not clearly visible at the surface. But here we see a permafrost landscape that is changing due to persistent and rapid warming. This early stage of degradation with the tops of ice wedges have melted and water accumulates in isolated ponds is now becoming a widespread phenomena in the Arctic. Since 1961 the global temperature has increased by nearly 1 degree, covering the start of the present normal period and the period where human influence has been the dominant cause of warming. In the Arctic, surface air temperature increased by more than double the global average and clearly shows the acceleration of warming in high latitudes. On Svalbard, the rate of warming is nearly 5 to 6 times the global average. Mechanism for Arctic amplification is still debated, but feedbacks from loss of summer sea ice is one of the major components. On September last year, this was the situation in the Arctic. Most of the summer sea ice is on the lowest time of the year, and this was actually the second lowest on record. But for Svalbard, what is special for Svalbard is the situation during winter. In mid-January last year, most of the Arctic Ocean was covered by sea ice. And that winter is a good example of how the situation looks like around Svalbard and the Barents region during the past 10-20 years. We see still a lot large areas with open water, and especially north and east of Svalbard we have still open water in winter. And this is a key to understand why Svalbard has, why the temperature on Svalbard has increased so much during the last decades. Normally we have very cold air masses coming from north, flowing over the ice towards Svalbard. But when these air masses enter open ocean, they are strongly modified due to the open ocean with heat exchange. And these air masses have contributed to most of the warming we now see on Svalbard during the last 20 to 30 years. And also the fjords. This is a picture from just outside Longyearbyen. And this picture also shows open ocean, no sea ice, and also contributes to the dramatic shift in winter temperatures during the last 20-30 years. If you look at the temperature record for these weather situations when air flowing from north and northeast over Svalbard, we see this dramatic shift in temperature since the late 1990s. Temperature now during the coldest days in winter are 5 to 10 degrees higher than 20-30 years ago. So this is the most important contributor to the strong warming we now see on Svalbard. Another major component of the cryosphere is the snow cover on land, and this is important because in Arctic snow covers the land up to 9 months every year, and it's highly influencing the surface energy budget, the ground thermal regime, and interacts with vegetation and ecosystems. And the Arctic land areas, they are always completely covered in winter, so the transition seasons in autumn and in spring is key when characterizing variability and change due to snow, relating to snow cover. And this graph is, in my opinion, under-communicated because this shows the change in snow cover extent in late spring, early summer, and it's a major contributor to the Arctic amplification and the Arctic transformation. because here we see a very strong decline in snow cover extent in the Arctic. About 6 million square kilometers of snow has disappeared since the satellite measurements began 40-50 years ago. And actually this decline is stronger than the decline in Arctic sea ice. So it's a larger area with has lost snow cover compared to the Arctic sea ice. This picture is a typical situation for Svalbard during the last 20 years. We now see increasing impacts of warm spells during midwinter due to increasing frequency and intensity of heavy rain and positive temperatures. This really impacts the snow cover. And this is also supported from our weather stations on Svalbard. We see a quite strong decline in the fraction of annual precipitation amount falling as snow. In some of the latest years, actually, our observers of Svalbard, they only measured 10 to 25% of the precipitation coming as snow. And this reflects the strong increase in wintertime rainfall on Svalbard. For the Arctic region in general, rain is actually projected to become the dominant form of precipitation during the end of this century. This is Ny-Ålesund in April 2012, just some months after one of the most heavy winter rain episodes we ever measured in the Arctic. During one day, 98 millimeter rainfall came, and over a 2-week period, 270 millimeter of rain came in Ny-Ålesund. And what is special with this picture, as you see, the ice is open. As I said earlier, we have this ice-free situation in the fjords, but now the ice is moving to the land areas. So most of the land is covered by thick basal ground ice, 20-30 centimeter thick ice, due to this heavy rainfall during midwinter. The research performed on Svalbard on how snow cover is affected by these warm spells is now it's a wide number of researchers and others that looks on this and try to understand how snow cover is affected by this strong warming. And actually the researchers, some of these researchers are in the international forefront on Svalbard. Especially related to how snow is, how this affects ecosystems, but also it's an important arena for interdisciplinary research between ecologists or biologists and geophysicists. But there are still fundamental knowledge gaps and scaling issues, how climate change influences the snow cover in the Arctic. And this is important also research questions in one of the projects that's now running on Svalbard. The so-called COAT project, Climate Ecological Observatory for Arctic Tundra. They now initiated a new pilot study that builds on existing snow protocols to monitor and get a broader or deeper understanding of how snow cover variability response to climate and climate change. So there are detailed measurements on snow cover in the landscape with measurements in different points to see how snow cover varies in terms of snow depth, but also ice layer inside the snow. They, for instance, measure the thickness of the ice cover at the ground surface in tens of several points in the landscape. Another major component of the cryosphere is permafrost, and this is now changing and warming at a global scale. This picture is from the northernmost Canada, Ellesmere Islands. Shows increasing frequency. This area shows an increasing frequency of rapid collapse of ice-rich permafrost. And such abrupt thaw have been highlighted in the latest IPCC report that came last year. That they conclude that permafrost regions appears to be vulnerable to abrupt thaw and causing this type of large changes in the landscape. And this is now also visible on Svalbard. We see clear signs of permafrost or similar phenomena that we see in northern Canada. This rapid thaw that visibly is changing the landscape. This is between Reindalen and Adventdal in Longyearbyen a few years ago. And we also start now to see sinkholes forming in completely undisturbed terrain, like here at Gjellhale in Sassendal in July 2017. And we have active layer detachment slides due to permafrost thawing in Hanaskogdalen after record high summer temperature that year. This was in August 2019. And these visible changes are well supported by our permafrost temperature monitoring. This is examples from Jansenhaugen on Svalbard. Annual temperature profiles from the surface down to 100-meter depth shows a clearly strong warming signal during the last 20 years. And the extreme warm year 2016 clearly stand out in the observational record. And similar warming rates are also observed at other monitoring sites on Svalbard, from Kapliné at the west coast to gentle mountain slopes in Endalen and mountain plateau at Breinosa. And lower warming rates are observed at some lowland sites outside Ny-Ålesund and Longyearbyen. And the differences between these sites are related to variations in snow cover, ground ice content, soil and bedrock type, and a degree of continuity. Last autumn we established new automatic full-scale weather stations in the part of Reindalen and in Adventdal, like here on Jansenhaugen on this picture. And the stations are the first two of several stations that will be established as part of the COAT project and CEO's Infranord program that are now running on Svalbard. And they will provide, this station will provide new knowledge of weather and climate gradients towards the inner and higher regions on Spitsbergen, where we currently have a very pure observational base. Most of our stations are located around the coast. So this station in inland areas are very welcome, and now there are a lot of research infrastructures that are built around these stations. And they also provide real-time data that ensure fast data access for other researchers and operational weather, avalanche forecasting, in addition to local rescue, tourism and general public. So, thank you.